Hi everyone, today let's solve the problem number 22, generate parenthesis, right? So what the question states here, we are given n pair of parentheses. We have been given n pair of parentheses here. You can clearly see n equals 3 they have mentioned. We have been given n pair of parentheses. We have to generate all the combinations of well-formed parentheses, all the combinations, combinatorics basically. So we have been given n pairs of parentheses here. We have to generate all the combinations of well formed parentheses. So what is well formed parenthesis here? A well formed parenthesis string has each opening matched with the each closing bracket here. So for the particular opening bracket we have to have the particular matched closed bracket here, right? So such combinations, all the combinations we need to return basically each opening parenthesis matched with a closing parenthesis. At any point closing brackets do not exceed opening brackets. So here opening or the closing brackets here, suppose if we consider closing bracket should not exceed the opening brackets, right? So that's the condition mainly. So here you can clearly see they have given n equals 3 from 3 brackets, so 3 parentheses opening and closing brackets. These are the combinations, all the valid combinations that can be formed by making use of the parenthesis, right? So 3 parentheses basically, right? Same goes with one. Here we have only one, this one opening and closing parenthesis. This is the only way, right? So I hope this part is completely clear, very easy to understand, right? So let's do one thing. Let's discuss the approach first, followed by the this one, what do you call, complexities, and then let's write the code. Let's come to the approach part here. We want to generate all the valid strings like this one, all the 6. Suppose for this we have 5, right? So n equals 3, we have 5 combinations here for this one. So let's go step by step here. Let's go step by step here. First thing here is we will start with an empty string. So we will start with an empty string. Before this one, let me tell you, we will be making use of the, or we will be going with the stacks approach. We'll, we'll be going with a stack approach. So just keep this in mind. First thing here is we will track the number of open. So before that one, we'll start with an empty string and an empty stack. We'll start with the empty string and empty stack here, right? So we will track the number of open and close brackets that is used so far. We'll track the number of open and close brackets that we have used so far, right? So we can push opening parenthesis if open count is less than n. If open count is less than n, then only we can push this one. Uh, what do we call? Uh, uh, Opening parenthesis. We can push opening parenthesis or the opening bracket if open count is less than n. We can push closing this one bracket, closing parenthesis, only if the close count is less than open count. This makes sense, right? So we can only push closing parenthesis if close count less than open count. So we will continue this until string length becomes 2 into n and push it to the result if valid. So that's what we'll be doing here. We'll continue this one till the string length becomes 2 into n, and then we will push into the result if it is valid. If it is not valid, then we'll not be pushing, right? So here this is fine. We will be going with a DFS recursion with a stack. Just remember this one. We'll be making use of the DFS recursion with a stack. Why? Because we have to validate the sequence dynamically as we build it, right? Suppose so this is valid, then we have to validate the sequence dynamically. So this we have to validate, this one also we have to validate, this one also we have to validate, because we can use 3, this one, what do we call here, n equals 3, right? 3 opening parenthesis and 3 closing parenthesis, right? So that's what. So we have to validate the sequence dynamically as we build it every step, right? So if it is not valid, then we'll not be pushing into the stack. So that is the reason we'll be making use of the DFS recursion with the stack we'll be using of anyhow. But we'll be going with the DFS recursion as well, right? So we'll be going with the DFS recursion, right? This problem is designed to be solved with the stacks basically, to be frank, right? So I hope the question part is completely clear along with the approach. I hope the question part is completely clear along with the approach, right? So let's do one thing. Let's quickly discuss the complexities before hopping into writing the code, right? So what would be the time complexity here? The time complexity would be 2 to the power of 2n. So here let's discuss this one. So I got confused here as well. The time complexity would be here in this case 2 to the power of 2n. Why it is 2 to the power of 2n here? Because each position has two choices. Each position has two choices, but only valid ones will be used. So here, suppose each this one position has two choices here. Suppose if we consider this one I'm speaking of, each position has two choices, but only valid ones are considered. Only valid ones are considered, right? So we'll not be pushing the invalid ones to the stack, basically, right? So we'll be pushing only the valid ones. So here each position has two choices, but only valid ones are used. And what would be the space complexity here? Space complexity would be quite obviously 2n. This is fine. So because we are going with the recursion, and for the recursion depth and building each string, we have to build each string, right? So in this case, the space complexity would be n plus n, nothing but the 2n here, stack plus call stack, right? So it would be 2n, right? The time complexity would be 2 to the power of 2n for the code that we'll be writing in the future, and the space complexity would be 2 to the power of n. Simple, right? So I hope the complexities part is completely clear along with the this one approach. Now as we are completely familiar with the approach and complexities, we are good to write the code. First, what shall we do? uh, let's do one thing. Let's make use of the list and the stack. List because we have to store the valid combinations, stack because we have to track the balance, and also we'll be going with the backtrack because we are going with the recursive backtracking here, right? I said we'll be going with the dfs and dfs recursion, right? So we will be going with the recursive backtracking here in this case. So first, initially, let's make use of the list here. Within the list, so this is string of this thing, right? It's considered as string. So let me pass the string here. Data type. So here this will be result and new array list. So this is fine. The next step here, let me make use of the stack here. Stack basically individual character. So I'll let me go with the character. So what happened to this one? So this I'll just give stack here. This one will be new stack. We have created stack, and this one what do we call? List and stack. So next step is we'll be going with the recursive backtracking. So we have not written the backtracking part yet. So backtrack part we have not written that function yet. So let's make use of the, or let's write the helper function backtrack, and then let's make use of it here, right? So here let me give private void backtrack. This is fine. Private void backtrack. So here this will be within the list, nothing but string. This is fine. I should have copy pasted. This is fine. This is basically result. This one. So let me copy this one and let me paste it over. Sorry. Let me type this one instead. So this is fine. So here this will be stack of character. So let me copy this one again. Yeah, let me paste this one, stack of, so this one have to go with this one, right? So this is fine. Let me copy this entire thing and let me paste it over here. Stack of character, stack. So this is fine, and we need current, and we have to go with the dfs recursion, right? So let's go with current, open, close, and maximum number of this thing that can be formed accordingly with the n, right? um so here what are the things that we need? Current, open, and close we need actually, and maximum we need, and current also we need. Yeah, let's do one thing. I'll just go with string current. This is fine. Int open. This is fine. Int close. This is fine. Int max. This is fine as well. So let's do one thing. Within this, within the helper function, this one, what do we call backtrack? Let's do one thing. Base case, what was the base case basically? If the total length is 2 into n. So if the current length 2 into n, in the space complexity, we discussed this one, right? If you remember. So we can write this one in this way. If current dot length, if it is equal to max into 2. So then what we'll do within the if condition, we have to add the valid sequence to the result. So this will be result dot add of current. So this will be result dot add of current. Means we are adding the sequence to the result. Here we will give return. We will give return. This is fine. So the next step is let's go with the simple if condition again. Means if we can add more this one. This is for if we can add more opening parenthesis. Means if open less than max, right? So then we can add the this one more opening parenthesis. So here this will be if open less than max, then what we need to do, we have to push the opening parenthesis to the stack. So this will be stack dot push of this one opening parenthesis. This is fine. So after successfully pushing the opening parenthesis to the stack, so we have to recurse. For recursing, we'll be making use of the backtrack function here, whatever we have written. So let's go with this one, backtrack. And what are all the things that we have to pass as parameters? One is result, stack, and let's go with current. Also, let's concatenate opening parenthesis here, let's go with open plus 1. So because we are pushing this one, right? We are pushing this one to the stack basically. If we have space, nothing but if, when open less than max. So also close, and then we need max, right? So this is fine. I hope this is clear. We are just recursing here, right? So recursion part. So next part is we have to backtrack. Means we have to remove the pushed opening parenthesis. For that one, we will be making use of the pop. This will be stack dot pop. This is fine. I hope this part is clear. Let me come out of this one entirely. Right. So here now we wrote the code. If we can add more opening parenthesis, what if we can add closing parenthesis only if it's less than the open count? If it's less than the open count, then we can add only the closing parenthesis, right? So for that one also, let's write the simple if condition. Here this will be if close less than open, then we have to add the closing parenthesis, right? So we will go with stack dot push. Instead of opening parenthesis, this will be closing parenthesis. This is fine. So the next step, after successfully pushing the closing parenthesis to the stack, then what we'll do, we have to recurse. So here in this case, let me copy the same exact thing and make the necessary changes. This will be backtrack of result, stack, current. This remains same. We are concatenating. Instead of opening parenthesis, this will be closing parenthesis, right? Instead of opening parenthesis, this will be closing parenthesis, and we have to add +1 to the, we are adding the closing parenthesis to the stack, not the opening parenthesis. This has to be close +1, not the open +1 here in this case, and max, this remains same. So next step, the final step, we have to backtrack and remove the pushed closing parenthesis. Let's go with the same line here, line number 17. Let me copy this one and let me paste it over here, right? So this is stack.pop. So we are just backtracking, means we are removing the pushed closing parenthesis here. So this is fine. So this is it for the backtrack function. Let me copy this one and let's make use of it within the main function, nothing but the generate parenthesis, right? Generate parenthesis. So here what we will do, we have to start the recursive backtracking. We are making use of the list and stack here within the main function, within the main class, basically generate parenthesis, right? Generate parenthesis function. So here what we need to do, we have to start the recursive backtracking. Here let me do one thing. Mm, let me paste this one, backtrack, and what are the parameters to start the recursive backtracking? We need a result. First of all, from this one, we need result from the backtrack function, and we need stack. Also we need we are starting with the empty, this one empty string. This we have discussed in the approach as well. We'll be starting with the empty string, if you remember, right? So if you remember the approach properly, exactly same thing that we are articulating in the form of code here, right? So after this one empty string, so we'll go with initially 0 comma 0 to n. This is fine. We are just starting the recursive backtracking here. So the final step is we have to return the result. we have to return the result, quite obviously. So this is it for the code. We are done with the code. Let me format the code once. I hope the coding part is completely clear, man. So let me hit the run button. I hope this works. Let's see. We have, so here let me leave the space where it is, line number 17. Mm, so we are concatenating this one, right? So this is fine. So again, in the line number 22, what we have, incompatible type string cannot be converted to character stack dot push here. Where line number 22, what's wrong here? Oh, so this one has to be single inverted comma, I believe. Yeah. So line number 23, what we have, bad operand type here, string for unary operator plus. Where, so yeah, we have to leave the space here. Where line number 23, so this is fine. So let me run this one now. I hope this works for all the this one. Sample dash. Still we have the error. Bad operand type string for unary operator plus. So where it is? Yeah, concatenate. So here line number 17. So we have backtrack here. So what we are doing here, we are just making use of recursion, or we are just going with the recurse, right? Result is fine. Stack is fine. So yeah, here I have given comma. So we don't have to give the comma here, right? So this is, we are concatenating the current with the opening, this one, what do we call? Opening parenthesis, basically. Now, the same mistake I've done here as well, I think. Yeah, in the line number 23, right? So let me remove this one. Yeah, now this has to work. Let's see. So yeah, here you can clearly see the sample test cases are getting passed. Means let me hit the submit button quickly. So I hope this works for all the test cases. Let's see. So yeah, here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So the code works absolutely correct in this case. I hope whatever the code that we have written is completely clear, and I hope the solution part is completely clear as well, along with the complexities and approach. For now, this is it. Thanks for watching, guys.